You guys ready to start class?
No, we aren't, but go ahead anyway.
I read what you posted, and you had the right instinct, I will say. That you wanted to solve for t.
Yeah.
There was one problem. This equation that you used is convenient, but it's not appropriate. Does anyone know where this equation comes from? T
Yeah, t equals
square root
horizontal
of 2 delta y over ay. Is that right? Is that the correct equation?
Yeah.
You know where that comes from?
When it's being dropped.
No, when it's being dropped.
When it's being dropped.
Right. It comes from this equation.
Say the equation, Dale, so the boys can know what you're talking about when you
What?
write it.
Comes from this equation, delta y is equal to VIY times t plus 1/2 AY t squared. Remember that equation?
Yeah.
Everybody have their equation books? This is the general equation you want to use when you're looking for a relationship between displacement, velocity, acceleration, and time. It's got all the elements: displacement, velocity, time, acceleration. So when all those things are in play, that's your go-to equation. Now, if you just drop something, what's VIY? Zero. So what happens to this when VIY is 0? Now delta y is equal to 1/2 AY t squared, right? Because this all goes to 0. Right? You taking notes, Mr. Dart? Doesn't look like it. What are you doing? Taking notes requires paper and pen. Do it. Or your tablet. So now you can solve for t. You can bring the 1/2 over here, right? 2 times delta y is equal to AY t squared, right? Divide by AY on both sides, and now you have 2 delta y over AY equals t squared. And your next step is there. So the only time you can use this equation is when VIY is 0, when the initial velocity is 0. It could be VIX, it could be VIY, whatever frame of reference you're using, but the initial velocity has to be 0.
You might want to mark that on your equation sheets. Just make a note on the paper.
So is it in our quiz problem, was VIY 0? No. So that was a bit of a misstep. But you can always use this. This is the equation you need to burn into your brain, even though this is easier to remember. This is the one you have to work with. So let's go back to the quiz question. and we do our drawing, right?
Mhm.
Basketball player. Gym floor. Hoop.
Mhm.
Ball. So this distance to the hoop is how much?
It's 3.5 meters.
3.5?
No, 3.0. Or 3.6.
3.05. Yeah.
3.05 meters. He's launching it from how far? How high?
2.05.
2.05. So here you got 2.05. So this distance, which is what? What's that distance?
From the player to the hoop.
From the
7.24. Oh,
1 meter.
1 meter. And that's our delta what?
Y.
Delta y. So here's our delta y. Because the ball is going to go right into the hoop. So what does the problem tell us about the initial conditions on the ball? Anybody?
like what's being acted upon?
Yeah, what, it tells us the angle that it's being shot at, right?
Yeah.
What's the angle?
35 degrees.
35 degrees. This is 35 degrees. Doesn't look like 35 degrees, but it is. Is that all we know?
Yeah, we know the
no.
distance from the player to the hoop. That's 7.4
Okay, so we know
meters.
how far?
7.24.
Okay, and then, is that all we know? This is our V that we're trying to find, right? V, what the question is asking is what's the speed of the ball, right, when it leaves his hand? Okay, we're going to call that V. All right, so V consists of an X and Y component, right? We know that, right? Right?
Yeah.
So if we break that down into Vx and Vy, what's Vx equal to in terms of V?
7.24.
No, it's supposed to be X.
It's what? Think trigonometry. What's Vx in terms of V?
7.24.
Make your triangle. Just, you can visualize this in your head, right? 35 degrees. Got V here. You got some Vy is here, right? And Vx is here. So what's Vx?
Distance from the ball to the...
Vx is the adjacent part of the triangle.
That's right. And so how can we express Vx in terms of V using trigonometry. Cosine theta, right?
Oh,
Equals what?
equals,
Vx over hypotenuse.
That's right. Vx over hypotenuse, which is V. So Vx is V times cosine of theta. That's going to be our x component of velocity. So if we know our x component of velocity, we know how much distance it has to go. Vx doesn't change, right? The only thing that's going to change in terms of velocity is what? What's going to change? What velocity is going to change?
The y velocity.
The y velocity. Vx is constant. The only thing that's going to change is Vy. And Vy is going to change because of what?
The arc.
Right, but what's causing that?
Gravity.
Gravity. Acceleration due to gravity. So the only thing in play here, Vx is constant. Vy is being acted on by an acceleration we call gravity. Okay, so Vy in this case is going to be what in terms of Vx?
Negative 9.8 meters per second squared.
I'm trying to get trigonometry. What's Vy in the same, set of relationships? Sine theta equals
Opposite over
opposite, which is what?
Vy.
Vy
over,
over V. So Vy is V times sine theta. Okay, so now we know Vx is equal to V times cosine of theta. And what else do we know about Vx in terms of your first instinct was to try to solve for time. That was a good first instinct. How do we bring time into this in the x direction? Vx is delta x over t, right?
Yeah.
This displacement over time. That's velocity. What's delta x?
delta x is 7.24 meters.
7.24 meters. So we can say that Vx is 7.24 meters over t. Now we can solve for t.
You need to write in the lit part of the board.
Okay. So this is also equal to V cosine theta, which is, V is what we're looking for, so we got to keep that into our equations. Your equations always have to have something in there that's going to tell you what you're looking for. So this is also V cosine theta, right? So T, when we solve this, for T, we have T is equal to 7.24 meters over V cosine theta, right? What's cosine of theta?
Theta is 35 degrees.
Yes.
So,
0.81. No, sorry, 0.82.
Oh, 0.82. Okay. 0.82.
Yeah.
So this, what's 7.24 divided by 0.82?
8.83.
7.82 divided by what?
8.83 meters over V.
No, 7.24.
Divided by what?
Divided by 0.8.
Sound right?
Yep.
Okay, so now we have T in terms of V. And so we know time. We don't know the number, but we have a little formula that represents time in terms of the variable that we're looking for. So now let's look at Y direction. What relationship, what formula are we going to use to express the motion of Y in the Y direction? Velocity in the Y direction.
Or V sine theta. Define.
I need to erase all this. Have you got it all in your notes?
Let me just finish it.
Vy is going to start out big, right? As big as it ever gets, right?
Mm-hmm.
And it's going to slow down, slow down, slow down, and it's going to stop, and then it's going to start coming back down again, right? In the Y direction. So what formula expresses that?
The one that the one that you showed us how to get to.
Yes. The very general one.
Yeah.
The delta Y equals VIY times T plus 1/2 AYT squared. That tells us what's happening in the Y direction. So, you got all this down?
Yeah.
I can erase it? Erase everything but that. Okay, so what's VIY? Let me give you a hint. VIY is V sine theta, right?
Yeah.
Delta Y, which we know, right?
Yeah.
What's delta Y?
1 meter.
1 meter. So 1 meter is equal to VIY times T, and we're going to use this for VIY. Before we do that, what's sine theta? What's sine of 35 degrees? Let's just solve that so we can get rid of all the
0.57.
Negative
0.57. Okay, so
0.
0.57 times V times T, right?
Yeah.
But what's T?
T.
We already figured out what T was, right?
Yeah.
So now we can substitute in that 8.83 meters over V plus 1/2 AY, which is what? Minus 9.8 meters per second squared, right?
Negative 4.9. Well, sorry, I had you at.
Well, yeah, we'll solve it
Yeah.
the next step. So that's AY. T, once again, over here, 8.83 meters over V squared. So now what do we have?
Yeah.
What do we have in this equation? We have only one variable, v. And that's the variable that we're trying to figure out. So all we have to do is do the math, and we can find v. Right?
Yeah.
And the way we did this is by divide and conquer. Figure out x, then figure out y. You got to divide and conquer. You can't do it all at once. Okay, so what's 0.57? My v's are going to cancel, right? Here, right?
Right.
So what's 0.57 times 8.83?
5.0331. So
5.03. All right, so, and that's meters, right?
yeah,
And what's 1/2 of 9.8? That's going to be minus, right? Because I have a negative number right here.
negative 4.9.
And what's 4.9? Let's see, let's do that in 2 steps. Okay, so 4.9, what's 8.83 squared?
77.96.
77.96. Let's call that 78. Over v squared, right?
Yeah.
What's 4.9 times 78?
382.2.
Negative
No.
382.
Stay on the,
Oh, okay, right
nope, you can't.
there. Okay, so this is what? 4.9 times 78 is what?
Negative 382.2.
I would have to write smaller next time. So this is equal to 5.03. I'm sorry, what was that number again? 4.9 times?
Negative 382.2.
Your best handwriting ever. So
382?
Yeah. 0.2. Negative
382.
0.2.
0.2. Over v squared. Right?
You getting that, you guys?
Mm-hmm. So now what can we do? And that's all equal to 1, right?
Mm-hmm.
1 meter. So we bring the 5 over 5.03 over here, right?
yeah.
And what happens when we do that? I need more space.
Okay, they're all down.
Take this guy's leg off. Okay, so when I bring the 5.03 over here, I get minus 5.03, right? Plus 1 is minus 4.03 meters. Right? They're both meters. That's the only way I can subtract them if they're both the same units. And then now I have minus 382.2 over here, right? 382.2 over v squared. So now I want to bring v over here, and I can multiply both sides by minus 1 and get rid of my minus sign, right?
Yeah.
So let's do that so we don't have to deal with these minuses. So we multiply both sides by v squared. And that gives us 4.03 meters times v squared equals 382.2, right? And that's we lost some units in here somewhere. This is meter squared. This was meter squared. Right? This is meters squared. And so my product here, I got to keep track of the units, right? So that's actually meters cubed per second squared. Okay, so now I can divide both sides by 4.03, right? And get V squared is equal to, what's 382.2 divided by 4.03?
94.838.
94.84. And one of my meters here, when I divide both sides by 4.03, that meters cubed becomes meters squared, right? One of my meters goes away. Which makes sense because V is meters per second, right? Meters squared has got to be what? I mean, V squared has got to be what? In terms of units.
Meters per second.
Squared. V squared has got to be meters squared per second squared. Your units always have to be right, and that's the way you can check to see you're doing the problem right. So now V, take the square root of both sides, 94.84 meters squared per second squared. Now my squares go away because I'm taking a square root. And I'm down to meters squared, and what's the square root of 94.8?
9.736.
9.74. There you got it. Michael Jordan is a physicist. You didn't know that, did you? So the math got a little hairy on this one. I apologize for that because there's a lot of
You're not
dividing and multiplying and stuff going on, but
Next
it's all
time I'll get
straightforward
to
math,
it.
right? It's all just pretty simple algebra, a little trig thrown in. This is the only trig you'll ever have to know in this class. So, clear? Divide and conquer. Figure out x. Figure out y. You could do it in the opposite direction also. If you knew the y displacement and you were trying to figure out Vx. So,
There is a glass of Diet Coke.
you got this?
Yeah.
Yeah. Here. And then you guys
Okay.
Okay.
I'm right in front of the camera.
So now we're going to do problem number 2 for the exam that we never got to. Oh, we'll get it for you.
Close the door.
Pause.
We can take it together again. Okay.
No, I think you may do it on the board. I don't know.
Yay!
Except for you to do.
Well,
I am.
I don't think he's not going to move on, you guys, until we get this motion stuff down. So we're not going to be racing ahead. We're going to get these motion things down. There'll be motion.
He'll wait till we're not stupid anymore and then let us get it stupid.
Okay. So Are you gonna do it on the board together? Yes.
I know you felt cheated yesterday because you didn't get both problems, so I'm gonna make up for it today.
Oh, thank you.
Okay. Somebody read it.
So,
Ooh, short.
Frankie, read it.
I don't have short problems.
If there were no air resistance, how fast would you have to throw a football at an initial 45-degree angle in order to complete an 80-meter pass? Is 80 meters longer than 100 yards? Because if so, this problem is just kind of stupid.
a meter is almost the same as a yard.
Okay.
Almost.
You missed this
A little bit. A little bit longer than a yard. Probably, what is it? A meter is 3.3 feet?
Like
It's like 10%.
25 feet.
Okay, Frankie, drawings, since you're a football expert here.
Okay. If there were no air resistance, how fast would you have to throw a football at an initial 45-degree angle in order to complete an 80-meter pass?
So draw it yourself.
So,
Let's see, if there's no air resistance,
draw yourself.
football field.
This is hard. Did you write?
Yes.
So she doesn't have that anymore.
Yeah.
Another piece.
That
Yes.
sucks for me, it's pretty good. Guy.
Okay, so Frankie, draw your picture high so you've got a lot of room, because you can only
Only
work on that, yeah,
Alright.
because that's all we're able to videotape.
Alright.
Okay, so help them out with the information, you guys.
Okay, so draw your little bib.
Yeah, draw your picture.
Make
Yeah.
sure he's buff. Got like his buff football.
What? Wait, what? Is that his arm?
Yes. Both of them.
Oh, both of them. Wait, what? Why are they
He's throwing the
connected?
football.
Dude, it's like a bullet.
His body's a gun.
He's a cyborg. And it's
Okay.
80 meters.
And then we'll draw another little dude over here trying to catch it.
I'm gonna get pain in the face.
Completes the pass and it lands in the guy's mouth.
This is 80 meters, right?
Yeah, 80 meters.
From his arm,
From,
Yeah.
right? From his arm.
This is good.
And for the purposes of this problem, you can also assume that the receiver is the same height as the quarterback.
Yeah, but he's
not
way in the
even 3D.
background.
yeah.
He's way in the background. It's perspective.
Yeah, art teacher.
I'm just saying that like, in the basketball problem we just talked about, the basketball hoop was higher.
Yeah.
So there was a delta Y. Is there a delta Y here?
If they're the same height.
No.
There's no delta Y. Okay. That's a hint.
Okay, what's your,
Delta Y equals 0.
Alright,
We mark that down.
Hey, delta 1 equals 0. We can use the weird problem that I like everyone else says.
That involves time.
Yeah.
okay, what else do we
I
know?
didn't say VIY was 0. I said delta Y was 0. Okay. Go ahead.
So ball goes.
What else do you know?
this placement of X.
Oh, the degrees.
Okay.
Angle.
45 degrees.
So, right there, right? Or-
Yeah.
It's pretty much like our basketball problem, right?
Mm-hmm.
Pretty close.
Okay.
Oh, wait. No, it's 45. Excellent.
45.
Yeah.
Make sure that's.
So, what's your strategy?
Write down your strategy.
Okay, so first we find time.
Frankie, write strat up there. There you go. You always start with what you want to end up with, right? Remember, you work backwards. So what do you want to find out?
So part of setting up the problem is labeling all of the variables. So like the speed, you're trying to find the speed that he's passing, right? How hard, what does it say?
How fast?
How fast does he have to throw it? So where is that on your diagram?
Hypotenuse equals the angle that Frankie's built.
So, just like that.
No, it's not like that, go.
That looks like the X direction, but they're not asking about how.
So V, right?
Right. Just like our basketball problem.
VY though, right?
Yeah.
Right?
That's
No,
not,
it's just
no,
V.
that's
Is that
V.
your-
VY is
Oh, that's just V.
the opposite part of the.
So V, that's what we're trying to find, right?
Yeah.
Okay.
So find V is step number 3. Find V is step number 3.
Yeah.
Not sure we know how many steps we're going to have to take, but it's definitely the last step.
And then 2, find formula, or no, let's just.
Dale, is it helpful for them to write down what they know, and then based on what they know, they can do their strategy?
Yeah, write down what you
Write down
know.
what you know to the
Over far right.
far right, like up in the by your little miniature guide.
Alright.
Okay, write down everything you know. What do you guys know?
Delta
Delta y is 0, right?
Yeah,
Delta y is 0. What else do you know?
delta x is 80 meters.
Delta x equals
80 meters.
80 meters.
Theta is 45 degrees.
Theta equals 45 degrees. What else do you know? Do you know T?
No.
T, you don't know, so just put T up there. Okay, you don't know.
VI, or V,
That's what we're looking for.
yeah.
Do you know a?
So,
So V, what is
Do you know any acceleration components?
that? We know the acceleration for Y.
yeah,
Okay.
Acceleration components AY. And what is AY?
9.8. Okay.
Yep.
How about AX?
Negative 9.8. What was it? Meters.
we
AY.
don't know.
Wait,
9.
would AX be 0?
0.
Because it's
No friction. That's why they said no friction. Didn't they say no air friction? If there was air friction, AX would not be 0. Then you'd have an even harder problem.
Don't get any ideas.
We'll get to friction sooner or later.
Okay. So, what else? I think
I
that
think
is
that's covered all.
Okay, so this is a really good thing for you guys to know. You should just get into the pattern of writing down delta y, delta x, theta, t, v, ay. What else? And look at everything you know. Now, based on what you know, look at your equations. Looks like is it like the other problem?
Good.
Delta X equals VIT. We don't have VI, so we're trying to find.
What was that
VI.
magic equation
We don't
Mr.
have
Behart
T,
said
so
you
we-
need to burn into your brain?
Something, something, T, something, something.
Yep, if you wrote, you should have written it down.
Go,
Oh,
find it.
yeah.
It's delta x equals.
Cool.
Delta 1.
Patty cake.
Here, Patty
Just wrote it down.
So, what did we do last time? We have an angle there. What do we want to do with that angle? Isn't that kind of a hint that we're going to have to use some trigonometry? You have to divide and conquer. You have to express what you know about the x direction and the y direction separately. So what do we know, what formulas do we have that can relate v to vx?
So it's delta x equals VIT
So I got to write that on the board.
plus 1 half AT squared. Because we know delta x, and we don't know VI.
VI 1. Yeah.
Vix
never
times
mind.
t.
Because we don't know VI. Yeah, never mind.
We didn't know vix in the last problem either, did we?
Yeah, we used the same equation. So, what is it?
I'm sure if you look at your notes,
Yeah.
you can see what we did last time, and you can apply the same principles.
Okay, so
VIY
it's
delta
VI, it's delta x equals VIT plus 1 half AT squared.
A x, which is what?
Zero.
0.
0. So what happens to the whole half of that last half of the equation?
It's 0.
Yeah, so
So
delta x,
I'll just write it out. So
delta x is equal
delta
to,
VIX.
that's right. And that makes sense because it's a constant velocity, right? No friction.
Say that again. Do you guys hear? Do you get the reasoning behind that? Say that again, Mr. Behart.
I said it's a constant velocity, so it makes sense that it would, your distance is just your velocity times time. If you're in a car going 60 miles an hour for an hour, how far do you go?
60 miles.
60 miles. It's the same thing right there. V is 60 miles an hour, T is 1 hour, delta x is 60 miles. If there's no acceleration, it's as simple as that. But if you step on the gas, the car is going to accelerate. Now it gets more complicated. Now you have to have the second part of that equation. The second part of the equation brings in the acceleration factors.
Because it's acceleration.
Okay, so
So VIX is 0, right?
VIX is not 0. What is
I
VIX?
don't know VIX.
What is VIX?
It's the initial velocity
Initial velocity
of the ball.
of the ball
In the x direction.
in the x direction. And what did we say that was last time? In the last problem?
Because
Sine, theta.
You wrote it down.
Check your notes.
Check your notes.
Cosine
Why
theta
you take
equals,
Cosine theta equals Vx over V.
yeah, that.
So VIX is
so VIX equals that, right? So, wait, is that?
I can't see
Uh,
what you're writing.
VIX is
Yeah.
what?
It's cosine theta, right?
Yeah.
Okay, cosine theta
Cosine theta equals Vx over V. Okay. So, cosine
I can do that.
45 degrees.
So plug in the
So,
numbers. The cosine of 45 degrees is,
The square root of 2 over 2.
What?
Or
What?
0.707.
No, I think you have your thing wrong. Cosine, how many degrees? 45? 0.525.
I got 0.707.
I think your calculators were doing it in like radians or something.
0.707.
Yep, that's what I got.
What? Okay, let me do that again.
What is it?
Cosine,
That's not
45.
Let's
Don't.
do it in radians. So.
0.525, I'm telling you. My answer's right. Go ahead.
The mom's answer's right.
what is it?
0.7.
Do your guys.
0.7.
And you guys think,
0.7 what?
0.71.
Okay, hang on a second.
Hey,
What's
what's
in
on
that?
that bracket?